let's start at the beginning. This is a trigonometry class. So let's talk about what is trigonometry, and it is literally measuring triangles. That's useful. It says right up front what's on the tin, what we're going to be doing. We're going to be measuring triangles. Let's talk about triangles and the parts therein. So, what's a triangle? It's a geometric form. It's got 3 sides, and it's also got 3 angles. I love it when things are named like they're supposed to be named. Everybody know X and Y coordinates? There's like an X coordinate and a Y coordinate. One of those is called the ordinate. The other one is called the abscissa. You know which one is which? Neither do I, but we come up with lots of names for things that don't make any sense at all. So it's really nice and refreshing when something called a triangle has triangles. So a triangle has 3 edges and 3 vertices. Vertices being the plural of vertex. Plural of vertex. This is not how we're going to think about triangles because we are going to be measuring triangles. So these 3 edges, we're going to call them by their more common name, sides. And the 3 edges and the 3 sides will give us 3 angles. The vertices are not necessarily angles, they're just points. Angles require not just a point, but also 2 sides or 2 edges to make an angle. Is that okay? Of course we're okay. I just defined what a triangle was. And you're like, oh, dude, we got this. This class is going to be easy. Oh, yeah, totally. So we have 3 sides. Sometimes we want to say if these sides are different lengths, it's very common to put marks on them. Say these 3 sides are different lengths. We might also want to do the same thing with the angles that happen at the vertices, but aren't actually the vertices. So like this angle, I'm going to put 1 little curve there to indicate the angle there. Then there's going to be another angle opposite this side with the 2 marks. So I'm going to put 2 little marks there. And then I'm going to put 3 marks in this angle. That will tell whoever's looking at this diagram that those 3 angles are all possibly different values. Now notice that this angle down here in the lower right corner has 3 marks on it, and that side has 3 marks on it. That side with the 3 marks we would say is opposite the angle with the 3 marks. The side with 3 marks is opposite the angle with 3 marks. We have 3 sides and 3 angles, and we want to establish a relationship between a particular side and a particular angle by referring to the side opposite the angle, or the angle opposite the side. It goes both ways. So if you're standing in an angle and have your hands on the 2 sides that make up that angle, the side that you're looking at is the side opposite that angle. Not if you're like, oh, I'm looking this way. Then you're just cheating. You knew what I meant. Just run with it. You know what I'm talking about? Like, don't be the teacher that's like when someone says, can I go to the bathroom? I don't know. Can you? Because you know what I meant. Incidentally, the boss move at that point is to pee yourself and say, yes, I can. Now, I guess we should apply a little bit of proper communication, because you knew what I meant. You know what I mean? Don't be deliberately obstinate by saying, oh, but I could see these sides if I lift sideburn. Stand in an angle, hands on each side, on the two sides that make up that angle, and then look straight ahead. That will be the side opposite. So the 3 marks on this side and the 3 marks on this angle indicate that this side, this 3 mark side, is opposite the 3 mark angle. That's what we mean by opposite. How's everybody okay? Yes. Oh, a pen. Oh, I don't know if this works. Triangle. Got triangles. That means 3 sides. And we want to talk about a side, opposite, and angle. Vocabulary. That's vocabulary for today. When we measure sides, they're just going to be lengths. Sides are just lengths. So anything that we could use to measure a length is something we could use to measure the side of a triangle. So things like centimeters, meters, inches, foots, miles. America. Foots. Football fields, another one of my favorite measurements. Football fields. I know we always make fun. We like to make fun of like measuring things in football fields, but picture 300 feet. Now picture a football field. Which one makes more sense? Oh, look, this sinkhole in this, this is my favorite example. There's a sinkhole, and the headline was sinkhole the size of 7 washing machines. And everybody laughed. Might call 5. The sinkhole was 2.5 meters long by 1.5 meters wide. How big was the sinkhole? Not really helpful. In fact, but the problem was they had a picture of the sinkhole, and there was like a minivan right next to it. And I was like, oh, sinkhole the size of a minivan. Because when I say that as a unit of measurement, you know what I'm talking about. What am I called? Oh man, there's a hole in the wall. Really? A fist-sized hole. Oh, okay. Someone had anger with you. It makes sense. It's a trigonometry law, exactly, right? But if I said, oh, there's a hole in the wall, measured approximately elliptical, measuring 8 inches wide by 6 inches high. Was that too big for a fist hole? Who knows, right? The measurements aren't helpful. Football fields are. Washing machines, a little bit weird, especially considering they could have just said the size of a minivan, because that was right in the picture. Dude, look at this sinkhole. They could have just had that. Dude, look at this sinkhole. And it's like, oh man, everybody would have come to the same conclusion. That sinkhole is the size of a minivan. That minivan escaped dropping into a sinkhole because it would have fit. But if we said that the sinkhole is 220 inches long, would that help? How does 220 inches compare to the size of a minivan? See? As if any of these are helpful. Oh, I'm sorry. 220 inches. Let's convert that to centimeters so you get a better idea of how long that is. Does that help? How does the minivan compare to 220 inches? Yards? Okay, so 220. I don't want to do the math. I'm not good at arithmetic. So, anyway, measuring things in minivans and washing machines, beside the point. Measuring things, measuring sides, we're going to use a length. I usually pick like inches or centimeters if I want to make the problem seem more important, like a big problem. I use meters. Whoa, that's a big one. But even if I said the triangle is 3 meters tall, people would like, if I'm like, oh, it's 300 centimeters, I go, whoa, that's big. Now's the question, measuring angles. What do we use to measure angles? You already know this. Yeah, math. Yes. Now, what are the units that we use to measure angles? Degrees. See, you guys know stuff already. I don't know why y'all were worried. Not degrees. Degrees. Shit, you already know stuff. We measure angles with degrees. Weird that we also use degrees for like temperature, but especially since temperature is like displayed always this way, and angles are for measuring, the degrees are for measuring angles. But what I'm saying is that Europe shouldn't be like poo-pooing America for measuring things in washing machines. That's all I'm saying. I bet you know a lot more about degrees. If I go take a line here and I make an angle and I go all the way around, how many degrees is that? You guys already know stuff. See? Yeah, this is going to be easy. 360 degrees. Anyone know another one for this one? Oh, we know 180. That's going to be half. So that's when we start breaking it into pieces. But yeah, that's an important one, 180. 90, what's 90? What's another name for a 90? A right angle. See how much you guys know already. My job going to be easy. I'm like, oh, my job's going to be easy. And the students are like, oh, challenge accepted. Awesome. Right angle. Cool. So we measure 360 and we just divide that 360 up into a bunch of angles. So if I have an angle that goes halfway between, it's all just fractions. So if here's a 90 and I go halfway up, 45 degrees. This one doesn't have a special name, but notice that two 45s make a 90. That makes sense because that's how 45 and 90 are related. If I take two 90s, I get a 180. If I take four 45s, I'll get a 180. If I take two 180s, I get a 360. It's just fractions of a circle. And we take we have 360 all the way around. This is because 360 is an awesome number. 360 is an awesome number. It's divisible by 2, it's divisible by 3, it's divisible by 4, it's divisible by 5 and 6 and 10. I skipped 7. It's divisible by 12. It's divisible by so many things. Why do we like numbers that are divisible by lots of things? Easier to manipulate them because fractions don't show up, right? Like a 1/5 of a circle, we see 360 divided by 5, and it is divisible by 5. I don't know what it is because that's math. 72? Yeah, 5 70s is 350, 5 2 is 10, 350 10. 350 10, 360. Pretty good. It's just a fraction of a circle, right? If it was 100 degrees, what's 1/6 of a circle? 100 over 6? A pain in the ass. That's what that would be. 360 is great because it's got lots of divisibility. Don't end up with fractions. I like it. So we already know some stuff about measuring angles. Does anybody know another way we measure angles? This is like secret knowledge. You don't have to have this one yet. Radians. Awesome. Was radians thinking? Radians? Anyone have another one? Washing machine. No, washing machines are for length and volume. No. Oh, half a cycle. That would be good. Yeah. Yes. Yeah, there's a pi involved in the radians. Anyone know what's radians? How many radians is any one of these? How many radians is the 360, 180, 90, 45? How many radians? Which one is pi over 4? Not quite. That would make sense. That's the problem. This is why you're going to not like radians. Because pi over 4 would make so much sense. But the ancient Greeks were dumb. Like, oh, pi should be the radius, the ratio of the diameter to the circumference. And I was like, oh, dude, use the radius. But I actually wasn't at that meeting because I don't go to meetings. I'm like, oh, so hey man, what happened at the meeting yesterday? So we defined pi. I'm like, oh yeah, what'd you use? It's the ratio of the the ratio of the circumference. I'm like, oh yeah, to the diameter. I'm like, oh, you guys, fucking idiots! You just made trigonometry so much harder. Why didn't you use the radius? I'm like, well, you know how Bob is about the diameter. He's all about the diameter. He said, well, you just put it in half. It's like, well, yeah, but that's a pain in the butt. You guys are idiots. So pi is actually half a circle. If you're thinking, the hell? Yeah, that is correct. So this is pi radians. It makes me so angry, I just use a capital pi, so don't at me. So 1 full circle is 2 pi radians. 1/4 of a circle is pi over 2 radians. I'm also making it as bad as possible, emphasizing the 1/4 and the 1/2 and stuff like that. Curse you, ancient Greece. You jerks. See any toes around anymore. So good. We do have this other way of measuring. And even though radians is not the right choice that we made, it's really important that we have these as an alternative to degrees, because we want to do things when we measure angles with more than just degrees. Degrees is too limiting, especially when we want to make the variable time and measure stuff that goes up and down like this. Any questions? How's everybody? Okay. It's really weird that in trigonometry, it's primarily measuring triangles, and we care about stuff that goes up and down like this. That's really important. We're using that constantly. Ooh. See what I'm doing there? Change the frequency. All in the freaking triangle. Weird. Let's take a break. Refill water. Refill water. I'm going to pause the video, so there's going to be multiple videos.